Welcome to this explainer. Look, I want you to think about this startling reality for a second. You're eating the exact same vegetables your grandparents ate, but you are absolutely not getting the same nutrition. We're going to dive into some hard, peer-reviewed data today to answer a massive question. Is it actually true that our food has drastically fewer minerals than it did back in 1950? And, maybe more importantly, how does the literal dirt beneath our feet directly dictate the health of our own bodies?
You know, we usually just assume that as long as our plates are piled high with fruits and veggies, we're doing exactly what we need to do for our health, right? But what if the very chemical makeup of that food has fundamentally changed? Because researchers have been documenting a severe mineral decline in our produce since the mid-20th century. This phenomenon is creating what scientists actually call a hidden hunger. So you might feel totally full, and you might be taking in plenty of calories, but on a microscopic, cellular level, your body's actually starving for essential trace minerals.
When you compare them side by side, the visual is super deceptive. I mean, today's broccoli might look identical to the 1950s version. Honestly, it might even look bigger and greener, but its internal architecture is completely different. The data shows that the calcium content of broccoli averaged about 12.9 milligrams per gram of plant tissue back in 1950. Fast forward to today, that number has plummeted down to just 4.4 milligrams. That means you'd have to eat almost 3 times as much modern broccoli just to get the exact same calcium your grandparents got from one single serving. That's wild.
And look, this isn't just some internet rumor. Biochemist Dr. Donald R. Davis and his team at the University of Texas at Austin conducted a landmark, highly rigorous study that was published in the Journal of the American College of Nutrition back in 2004. They didn't just sample a couple of local farms, they pored over historical USDA data for 43 different garden crops, comparing the nutrient levels from 1950 all the way through to 1999. By adjusting everything to a dry weight basis, which basically removes the variable of water content, they isolated the undeniable truth about what's actually happening to our food supply.
The sheer scale of this nutrient collapse is just staggering. Across all 43 of those crops, Davis and his team found statistically significant drops in essential minerals and vitamins across the board. We're talking median declines of 16% for calcium, 15% for iron, and 15% for vitamin C. This isn't just one bad crop year or one specific plant acting up. This is a systemic degradation of the nutritional baseline of our entire agricultural system.
But perhaps the most shocking discovery in the data? There was a 38% drop in riboflavin, which you probably know as vitamin B2. I mean, when declines are approaching that 40% mark, it becomes crystal clear that modern commercial agriculture has a severe nutritional cost. We've successfully engineered our food to grow faster and fight off pests, but in the process, we've accidentally stripped it of the very compounds our bodies desperately require to function, to keep our immunity up and to prevent disease.
And this isn't just an American issue either. It's absolutely a global crisis. There is a comprehensive analysis of long-term data from the UK's Composition of Foods tables, tracking mineral content from 1940 all the way to 2019. The findings there are just as staggering. Over that 80-year span, sodium dropped by 52%, iron by 50%, and copper by 49%. Think about that. Trace elements that are vital for our biological functions have effectively been cut in half. The researcher specifically noted that these reductions make a bad situation even worse, especially for teenagers and vulnerable populations who might already have nutrient-poor diets.
So why exactly is this happening? Well, a major driver here is what agronomists call the dilution effect. For decades, plant breeders have been selecting crops based on some very specific economic traits: size, rapid growth rate, high yields, and pest resistance. But as these crops are genetically pushed to accumulate carbohydrates and water at this explosive rate to grow bigger and faster, their root systems just cannot keep up. They simply don't have the ability to suck up minerals from the soil fast enough to match their physical growth. The end result? A giant, beautiful-looking vegetable that is almost entirely nutritionally diluted. Which brings us to the actual physical root of the problem, the dirt itself. See, true soil fertility requires this incredibly intricate balance of biological, physical, and chemical properties. It's a complex, living ecosystem. If you just have the physical dirt and a few chemical elements, you're completely missing the biosphere, the plants, the animals, and the microbes. Without that bustling biological activity, the minerals could be sitting right there on the ground, right next to the roots, but they remain completely locked away and totally unavailable to the plant.
And that's where the living soil microbiome comes in, especially this incredible network of organisms called mycorrhizal fungi. They are the true heroes here. These microscopic fungi act almost like an extension of the plant's root system.
Think of them like a human gut. In your body, your gut microbiome breaks down your food so your intestines can absorb it. In the ground, mycorrhizal fungi break down complex earth minerals and deliver them straight into the plant's roots. They are literally the missing biological link that makes minerals plant available in the first place.
This gives us a super powerful analogy from the research. Intensive industrial farming practices rely heavily on deep, continuous tilling and widespread agrochemical use. And what happens when you do that? Well, as the research puts it, tilling soil then is the equivalent of stripping the gut of bacteria by depriving it of fiber-rich whole foods and over-consuming antibiotics. Just as pounding antibiotics destroys your gut health, intensive industrial practices completely wipe out that crucial soil microbiome. When we kill the soil life, we literally sever the exact mechanism that brings iron, zinc, and calcium into our food.
Because of this, commercial agriculture has to rely almost entirely on conventional synthetic fertilizers, mostly that nitrogen, phosphorus, and potassium, or NPK, that you see on the bags at the store. But by bypassing the natural nutrient cycle, we're forcing the plant to grow incredibly fast while masking the fact that the soil is degraded. Because the natural biological web is dead, the plant just cannot extract those essential, life-giving trace minerals like magnesium, copper, and iron. It creates massive crop yields, sure, but it results in total nutritional bankruptcy.
All right, now that we understand this deep connection between degraded soil and our own personal health, the good news is we aren't powerless. Here are some totally actionable steps you can take to actually access truly nutrient-dense food. First up, as a consumer, try to seek out organically or regeneratively grown produce. Studies clearly show that these farming systems focus on managing soil organic matter, which enhances microbial biodiversity and mineral uptake. Now, if you're a home gardener, plant deep-rooted perennials. They physically mine minerals from deeper, undisturbed soil. Rely on compost to build up your soil organic matter instead of throwing synthetic NPK at it. And most importantly, avoid tilling your home gardens so you can protect and nurture that vital soil microbiology. As we wrap up this explainer, I want to leave you with a final thought to chew on. We really cannot separate human health from soil health. They're entirely intertwined. The calcium in your bones and the iron in your blood literally have to pass through the complex living web of the soil microbiome first. Knowing that healthy, living dirt is the absolute foundation of healthy bodies, will you ever look at a vegetable or the ground it grew in the exact same way again?